Alright, so we have a 202 by 202 matrix A. It's kind of arbitrary, but whatever. And the 2 norm is 100, and the F norm is 101. We want the sharpest possible lower bound on the 2 norm condition number kappa of A. So let's see, our A is a 202 by 202 matrix, so it has singular values sigma 1 through sigma 202. And of course, these are listed in decreasing order, and these are all positive. So let's see. We know that sigma 1 is the 2 norm of A. That's something that we've proven, and that we know is equal to 100. So what we're going to prove is that the sharpest possible bound on sigma 202 is that sigma 202 must be less than or equal to 1. So to prove this, first of all, let's suppose that you choose some sigma 202. Let's suppose it were the case that sigma 202 were greater than 1. Then sigma I would have to be greater than 1 for every single I, because for each I, sigma I would be greater than or equal to sigma 202, which is strictly greater than 1. So this holds, and so we have the F norm of A is given by this thing, because this is just what the F norm is. And so if we break this up, this isn't just what the F norm is. This is something that we've proven about the F norm. The F norm is the square root of the sum of the squares of the singular values. Okay, so if we do this, then what happens? So we can write this sum as we have sigma 1 squared plus the remainder of the sigma I squareds. So this sigma 1 squared is equal to 100 squared, and each sigma I is greater than 1, so this sum is going to be strictly greater than the sum from I equals 2 to 202 of sigma I squared. So in particular, it's greater than the sum from 2 to 202 of 1, which is just 202. So this expression is strictly greater than this expression. If you write this out, this gives you 10,201, and the square root of that is 101. So if sigma 202 is strictly greater than 1, then the F norm of A is strictly greater than 101. But we're told that the F norm of A is exactly equal to 101, and so therefore it cannot be the case that sigma 2 is greater than 1. So if it's not true that sigma 202 is greater than 1, then we can conclude that sigma 202 is less than or equal to 1. Now this doesn't, it should be sort of, just from looking at this, you should sort of see, since this bound here between sigma I squared or the sum of the sigma I squareds and the 201, this looks like it should be sharp. So you might think that this inequality is sharp, and that's true, but we have to prove it. So it's true that sigma 202 is less than or equal to 1, but just from this statement alone, there's no reason, say, maybe sigma 202 is actually less than or equal to 1/2. And if sigma 202 is less than or equal to 1/2, then in particular it will be true that sigma 202 is less than or equal to 1. However, to prove that this bound is sharp, we need to give an example of a matrix which will have sigma 202 equal to 1. And so that's not difficult, because let's just say we have a matrix A whose singular values between sigma 2 and sigma 202 are all precisely equal to 1. So in this case, sigma 202 is equal to 1, and we know all the singular values here. And obviously, if we prescribe these singular values, then we can, because these singular values satisfy everything that we need singular values to satisfy. You have sigma 1 is 100, and then the remaining singular values are positive numbers, and they're listed in decreasing order. So you can make a matrix from these singular values which has these singular values. And so then what do we know from here? Then the F norm of A, well, certainly the 2 norm of A is going to be 100, because we've chosen sigma 1 to be 100, which has to be the 2 norm of A. But then we also need to check that the F norm of A is 101. And in fact, we checked that the f norm of A is just the square root of the sum. And so, again, we break this up into sigma 1 squared, which is 100 squared. And then the sum from I equals 2 to 202 of sigma I squared is just going to be 201. And this is going to be precisely 101. So there does indeed exist a matrix that has 2 norm 100 and f norm 101, and such that sigma 202 is equal to 1. So therefore, this bound, sigma 202 is less than or equal to 1, this is a sharp bound. And so this leads to the sharpest possible lower bound on kappa A, given by, so we know that kappa A, because this is a 2 norm condition number, it's equal to sigma 1 divided by sigma 202. And since sigma 202 is less than or equal to 1, 1 over sigma 202 is greater than or equal to 1. And this inequality is sharp. So we replace the sigma 202 by 1, and well, sigma 1, that's just 100, so we have this, and so this is 100. And so we have found the largest possible lower bound on kappa A. Specifically, it's 100, and there we go. This completes the exercise.